with this, just want to thank you. Well, I want to thank Tom for doing all the work for that, but just I want to give you guys an opportunity to just see what 35 questions randomly selected kind of feels like. If you haven't signed up for that hamstudy.org where they have the flashcards,
Haven't had the time.
that's very similar to what this is, and that's really useful because then you get exposure to all the questions. Wire. So that's something that I very much recommend, besides just reading the chapters, is to go onto that website and go through questions, go through the study card, look at the explanations behind the study cards, and then take some of the practice tests. And if you're consistently scoring, 85, 90% of the time, or 90% like all the time, start studying for the general as well. Like that would not be unreasonable because you're paying for one test session. You can take multiple tests in that session. So, welcome again. This is the same information, instructor information. So next class is going to be Monday, November 5th. So now we have a really nice schedule where we go Monday, Monday, Monday. And then on the 19th, we're going to do our testing session. And Tom will talk to you about
Monday,
schedules
November 5th through 7th?
November 5th, 7 p.m., 7 to 8:30 p.m.
Oh.
You have the question material, and I just kind of you have the study material. Make sure you write down questions during class, ask those questions, and then we're going to cover those those sections. And then afterwards, read the next section, do the study cards. Does anybody have any questions from the reading? Or just questions in general? This is what we call wait time. Still have you for another 58 minutes. I've got plenty of wait time.
No, it was on the radiation, it says 50 watts peak, what is peak?
Okay, so we're going to talk about that today.
Maximum
Tonight.
energy output.
That is peak envelope power. So that means that at the antenna, if it radiates more than 50 watts, I forget exactly what the envelope part of that, but the peak amount of power that it generates. If it generates more than that, then you have to do a radiation exposure, what is it called? Radiation exposure evaluation. So like my antenna, since we have a 100-watt rig, if we're, anywhere close to it, we have to be concerned with, cooking ourselves. And it's not like, I'm going to die from it, but, you could get an RF burn and that would not be very fun. If you're running like a hot
burn.
radiation burn. So it's, we're going to talk about that as a non-ionizing radiation. So it's not like being burned with like nuclear material or anything like that. It's being like cooked like you would a hot dog in a microwave.
Radiation.
Yeah, so we're at a lower frequency than microwave radiation, but it can still hurt your flesh. And so they like to talk about doing RF exposure measurements because your tissues interact with that radiation in some way, shape, or form. Even this Wi-Fi router here is putting off 2.4 gigahertz of radiation in about 2.4 gigahertz. That's still interacting with my.
Have to emit radiation nowadays.
Yeah, but that's interacting with our tissues. Some not so much.
It blows holes in our tissues every second.
Not necessary. Some of it just passes through. But some. Jacob,
Doctor and he knows.
So some of it passes through you unimpeded, and some of it, when we talk about 50 megahertz, that's the frequency that affects our tissues the most, and so that's the one that we got to be really worried about. That answer your question? Okay. Any other questions? Okay, well, if you have more questions, go ahead and ask them. So tonight we're going to cover amateur radio signals and electrical safety, which electrical safety is more like electrical safety, tower safety, and RF safety. And so we want to start off talking about modulation. So on, I think probably the fourth slide you have, we talk about, you have the definitions for frequency modulation, amplitude modulation, and single sideband phone. So these are things that,
LSB, what does that mean?
I'll get to that in a second. So with frequency modulation, we're talking move or changing the frequency at which, so you're on a frequency, but then you also have what we call bandwidth. So you're not on that one frequency. You actually deviate a bit as you talk. So your voice transmits through the RF carrier and it begins augmenting that. And so it's augmented through combining your RF carrier with an information signal, generally your voice. In FM modulation, you can also do data. So we'll talk about like APRS and other things that for you search and rescue guys that might be more interesting to you. And so that information actually changes the RF carrier and is modulated in the process. So that other receivers can pick that up through their antenna, demodulate it, and then play it over their speakers so it sounds like someone's talking to you. Frequency modulation, FM. The FM and AM are very similar, or the exact same, as when you turn on your radio. You know, you're listening to 97.3 or NPR, whatever, that's FM. You know, you're listening to the local KSL, that's AM modulation. That your car stereo is receiving, demodulating, and playing out loud. So amplitude modulation is something that we'll run into a lot on HF frequencies, where we combine information and your RF, so similar to like frequency modulation. So we take our RF carrier and our voice for this instance, we combine them, and then this is what a normal AM signal looks like. You've got your carrier, so that's the frequency that you tune your radio to, and then normal AM frequencies are what we call double sideband. It's got the upper sideband and a mirror image on its lower sideband. And so that takes a lot of energy to generate the carrier, generate your upper sideband, and generate your lower sideband. And as you speak, or as your broadcaster is speaking, it's generating this mirror image and changing the amplitude, so the peak of your signal, up as it encodes that information. And then the fun thing is with single sideband, when we're talking on the radio, we actually get rid of most of this. So your 100-watt transmitter is transmitting only one of the sidebands and not the carrier. Because if we transmit the carrier, that's a lot of energy that's wasted. If we transmit both sidebands, we don't need that. So that's a lot of wasted energy. So we just transmit one sideband here, save a lot of energy, and then the other person's radio does the work entering a carrier and then demodulating it. So that's why, so when you're tuned into this frequency, your radio is actually pulling out that sideband, adding your own carrier, and then processing it so that you can hear what the other person's saying. That's really cool. So it's a really efficient way of using your radio transmissions. Because FM uses a lot of power to send your voice. AM uses a lot of power to send your voice as well. But if we take apart, well, I guess there it is. If we take that apart and chunk it up into one of its sidebands, then it's a lot more efficient transmission of energy. So that gives us the ability to have a 100-watt station that then transmits, halfway around the world. Modulation, it's important. And so really we're just talking about two different ways of encoding your voice or your transmission. So one way using frequency modulation, one using amplitude modulation. And so FM is most commonly found in like your handheld transmitter. So in VHF and UHF frequencies. We also talk about packet transmissions, which we will talk about in another slide. So right now I just want to talk about voice. And then AM is a really common way of transmitting information on the high frequency bands. So we're talking anything from 3 megahertz all the way to 30 megahertz. And so we remember breaking up the bands. We have high frequency from 3 to 30 megahertz. We have VHF from 30 to 300. And then we have UHF from 300 to 3000 megahertz. Everyone cool with that? And then here, when to use upper sideband and when to use lower sideband. Because here, we have this mirror image. And we have on one side the upper sideband, and on the other side, on the mirror side, we have lower sideband. And so there's actually no real advantage for using upper sideband or lower sideband other than at 10 megahertz, everyone that's above that frequency, like if they're on the 28 megahertz frequency, which is 20 meters, then they're all on upper sideband. But below 10 megahertz, so if you're on 40 megahertz at about 7 megahertz, or if you're on 40 meter band, which is about 7 megahertz, then they're all on lower sideband. So it just depends on where you are. And so there's this special, just remember 10 megahertz is your divider. So everything above that, upper sideband, below that, lower sideband. And it's just how people do it. I did find some research on how it goes back to how military transmitters were designed, and people just took on those characteristics in the civilian world and just called it good. And
isn't that primarily a decision that's made by the transmitter itself, not by you?
I will say that a lot of transmitters default to, so my transmitter, when I turn it on, if I go to the 40 meter band and turn it to like 7.3 megahertz, for instance, it will default and say we're on the lower side band. But I can change it to be double sideband, upper sideband, whatever I want. Just nobody's really on that band in upper sideband, so it doesn't matter. So nobody will hear me anyway, unless I have a special, friend that I want to contact and we want to be on upper sideband, and people that try to tune into us just hear garbage.
So you could talk pretty freely if the other person knows that you're gonna be talking in that particular band.
Yeah. But I mean, really, all someone would have to do is just push a button and then it would go to upper sideband and they could hear you. So it wouldn't be like encoding your signal, which, by the way, one of the things that we'll run into with rules and regulations, you can't really encode your signal because that violates FCC Part 97 or something like that. So encoding, using ciphers, not really that cool. Using 10 code really isn't that common on the ham bands. So they usually like to just use common language. Unless you're talking to people from Georgia, then you gotta talk with a drawl. Yeah. And then the nice thing is with single sideband, it has a really narrow bandwidth because you could be talking to people all over the world, all over the country. And so there's a lot of operators who could possibly be on the air. Single sideband uses only about 3 kilohertz. It's more like 2.4-ish or so kilohertz of bandwidth. So that's super narrow. If you look at FM voice that's on like your handy-talkie, which I really hate that term, it's handheld transceiver, it uses between 10 and 15 kilohertz of bandwidth. So you're using 5 times as much bandwidth talking on your handheld versus your base station. And so it's kind of a matter of scale. So like in your handheld region, we've got about 4 megahertz of bandwidth to play with in VHF. Well, that's not a big deal because I could only go, 30, 40, 50 miles and affect that small of an area. If I'm on the HF frequencies, I'm affecting things on a more regional or even countrywide scale. So, having a really narrow bandwidth there, that's really important. Having a narrow bandwidth when we're talking about our handheld radio, not as big a deal, unless you get to cities where it could be really congested. Cool. So, Tom, we're going to talk about CW. know how much Tom loves CW. But first, I want to talk to you. Here's a couple random questions about slow scan and fast scan analog TV. So with fast scan analog TV, ham users can actually get on there, set up a station, and transmit video signals, which is kind of cool. There's certain like chunks of bandwidth that people kind of reserve for that. And those bandwidths are 6 megahertz. So these are huge because they're encoding video and audio in this, giant chunk of information. And they're also transmitting at a really high duty cycle, which we'll talk about duty cycles later. So I don't know, you probably have to specially cool their equipment for that. And so fast scan TV, we're really not going to be messing with it. There's just like one question on the test that just mentions that. And the only thing you need to know about fast scan TV is that it occupies a bandwidth of about 6 megahertz. Ed, you have a question?
There's no compression in that, is there?
I don't believe so. I think it's pretty low loss. Yeah, but then over the airwaves, it's not going to be like coming into your station at really high fidelity anyway, but that's why they don't want to do it on their end. But then they have to have a pretty beefy transmitter to get that signal out, at least to the regional areas. Interesting history there is that the analog ham radio analog fast scan TV was some of the first public broadcast systems in some cities. Like in the 60s, some places didn't have that, and ham radio operators that would give them the news. Just kind of interesting. And you can tune to if there is a ham radio station that is doing fast scan TV, you can actually tune it with regular TV with rabbit ears or one of those. Most of those ones that you just stick up on the wall, those antennas, those are digital. But as long as you had an analog antenna, you could pick those up. Slow scan TV isn't really TV at all. It's just sending a picture. And it takes about 2 minutes, which is like a minute 52, to get one single picture to you. And it sounds atrocious. It just sounds like a fax machine booting up. But it just, so people use this to send wirelessly their calling card. That's what they call it, QSL card? Tom, QSL card? Okay, just making sure I got my Q
Terminology.
Yeah, terminology correct. But so people people who are really into communicating long distances, they design a nice picture and put their call sign in there, maybe some information about themselves. And then after they're done talking to someone, they can hit the send button and it will send this 2-minute really scary sound, but then the receiving person decodes that and they've got their calling card. And then they can send one back and they can print them off and put them on their wall. They used to, they still do a lot where people actually send postcards to each other, but the digital age, it's kind of fun to send that way too. Question, Jacob?
So you're saying these people send modulated frequency, EM frequency sound waves through the ham radio, and it makes a giant screeching tone that drives you crazy, and you have to decode it into a frequency in order to listen to this person.
Well, you two see the
That
picture.
is bull crap.
Well, then don't participate in it. So then I also want to talk to you about CW, which stands for continuous wave. And so this actually, so everyone usually just calls it Morse code, but it uses a frequency or a bandwidth of about 150 hertz. So super limited bandwidth. And so you can get a lot of conversations going on in a very short span. And so some fun facts is that CW uses a form of communication called International Morse code. And you guys, once you pass your test, are able to operate CW on pretty much everything above 80 meters. So you get 80, 40, 10, 15, 10, VHF and UHF frequencies. So on VHF and UHF, you've got full voice, FM voice capabilities, but also you can do CW. So if you're getting close to, you've got your rig you can build some interesting CW only rigs for fairly inexpensive, and you can talk with people like, next
Halfway
street
around the
order.
world.
Yeah, halfway around the world, and because it's a really narrow bandwidth, you can get really efficient transmission of signals. And then here is so this is an electronic keyer. It's just a device to help you send your Morse code to your radio to then transmit out. There's a lot of different kinds. The only thing that the tech level requires is that you just know this is an electronic keyer. Packet radio. So this is something that will probably be more interesting to you guys in search and rescue. Is packet radio just breaks your signal into small packets to then transmit incrementally to another station. And so so when you're working in a digital mode, they go through 3 different things and 3 different advantages here. They have a checksum error detection. So a checksum is like asking the computer, like, how many characters did that last transmission have? If you only got 51 and there's 60 characters in there, you can actually send an ARQ, which is an automatic repeat request. And then also you can have a header that has a bunch of information, like, if I'm sending a digital signal. So if you're sending, let's say I'm talking to Ed, either Ed, and so I'm sending my signal. It also comes with a header that then says, hey, this is from KI7 URL, and maybe even gives my map location is DN73, which I think is where we're at. And so that header information, so you're looking on your computer screen, you can see this info, you can talk to me, and some of it's just like a chat room. Like, we'll talk about PSK31, which is just like having a chat room on your computer, but instead of being hooked to the internet, it's sending it through the airwaves, which is pretty cool. And then ARQ just stands for automatic repeat request, just because if there's an error, it likes to send a signal again or send a signal twice just to make sure that this message was received without errors. And the without error thing is really important because some people use this for like emergency response. And if there are errors in the message, that can cause problems. The thing that you guys might be interested in is APRS, which is Automatic Packet Reporting System. And so combining your radio with a GPS allows you to send this sound that sounds like a burp over the airwaves at like 143 point something, I forget the exact frequency, but it allows you to then send that signal to a iGate. And that iGate will then take that signal and put you on Google Maps or APRS-Fi, which is one that I use. But then you can see where people are moving around. So for you search and rescue guys, if you have an APRS transmitter on you, you have 4 or 5?
How many of the trackers do we have? 4.
Cool. So your tracker can then, as you're walking around, whoever's at your command post or whatever, can then say, well, Ed's over here, and Tom's over here, and we want you to be here. It makes it a lot easier to coordinate. Or you can also send short text messages through it. So if you're driving down the road and you just want to tell people that you're listening on a given frequency, they can have, hopefully they're not doing it while they're driving, but they can have like their significant other looking at who's nearby, and they can say, oh, this guy's on this frequency, give him a call. Or if you're hiking up a mountain and you're like, this is the frequency I'm listening on, you know where I'm at, give me a hello. So that's really cool. The interesting thing is that if you have, like even some of the cheap like Baofeng radios, with a double-ended auxiliary cord, you can actually use your phone's GPS to then send that burp signal to your radio through like a voice-activated arrangement, which is a little cumbersome, but kind of cool because you probably have a smartphone already and your radio costs you like $40. But yeah, so the APRS, this is as much as the tech level goes into it, but for you guys, that's the cool thing, is being able to be out in the field and know where each other are. Super useful. And
So it goes from your smartphone to the actual little radio, or the other way around?
so some radios have the GPS built into the radio, so it just says start tracking and then it does it automatically.
That's not the one.
Okay, so then the one I'm talking about is an Android app that then sets it up to then send that signal out at a given frequency in a different time. And I just have to tell my radio that whenever it gets a signal from the mic port, to then send that automatically.
Got it, okay.
And so it just sits there, and I haven't used it for a little while, but I just pull that up. I go to APRS Droid is the program I use, and then I just tell it start tracking. I turn my volume up, and then it's doing it as 10 position. Oh, it's a little more annoying than a burp. But yeah, it'll just send that every 30 seconds or so, give my call sign, my frequency I tell them I'm listening on, and then it also says, hey, I'm also on APRS today. I'll just stop that. If you have an iPhone, I don't know what that is, but I assume there's a similar program you could use.
Okay.
But since that's outside the scope of this, we can talk later about how to set that up. Ed, do you have a question?
Isn't it with, somebody's trying to get me to get a Grumman, pardon me?
Garmin?
Yeah, sorry, Garmin.
Okay,
Radio that has that already pre-built in.
okay, so I don't know if those are like APRS, there's like MURS, which is another
So there's
reporting
different-
system. Yeah,
Class of that idea.
yeah, so, ham radios, they use the APRS. They use the APRS, but other modes do use other devices. Some of them, instead of a smartphone, you can actually get a terminal node controller and hook that into your radio, and then it goes between a GPS and like a full handheld Garmin to your radio and controls it that way. I just use my smartphone because I always have that on me and I don't always have a GPS on me. But yeah, so that's really interesting. But yeah, so then that signal gets transmitted and it has that information about where I am, my latitude, longitude, down to, well, since I'm in the building, like probably 50 feet or something. But then if I'm outside in the, in the open air, like it can be within like 10 feet or so, which for the most parts, if I'm on a search and rescue party, like looking for a lost hiker, being in a small, like a 10 foot by 10 foot area is not that big a deal. But yeah, so other digital modes that we want to talk about, PSK31, which stands for phase shift keying, and it operates at about so its bandwidth is about 31 hertz, and its baud rate is also about 31 bits per second. I think it's bits, yeah, and yeah, bits per second. And so PSK31 sounds kind of like a flute or so, just making these trilling sounds, because it's just shifting its, so it's doing a phase shift. So if you're set up to listening to voice and you get down into the lower parts of your, into like the data section, because each band has like voice and then some data. If you get down to the data and you start listening to that, it sounds like, someone on a piccolo having like a jam session, but that's them shifting the phase, and it's about 31 baud, which means it's about as fast as like a person types. So it's really good for that like chat room feel. FT8 is also really important because it transmits 15 seconds on, turns off, transmits for another 15 seconds. So it's not that good for like a chat room. It's more for like how people text. Jacob. So it's more for like how people text, like I'm developing a message, sending it. You're developing a message, send it. And so that is really becoming more popular because it operates below with really, really low noise or signal to noise ratios. So sometimes I've heard that they'll operate like a couple S units below the noise threshold because it's so efficient. It's like able to pull those signals out of the noise. And so right now we have a really bad sunspot cycle. We're in a bad spot in our sunspot cycle. So being able to communicate long distances, even though there's a lot of noise and the band is essentially dead, like that's a good way of sending a signal, receiving something. Jacob?
If there is a huge solar flare that affects the power grid for a long term of time, the best way that you can protect your ham radio during that period of time is to put it in a Faraday cage. It's
Okay.
a pure metal box
All right, Jacob, the design of Faraday cages isn't necessarily
with
relevant
a
to this.
non-metallic material inside.
So another thing, DMR, which I kind of want to get into this, so I haven't really been like really deep into this, but it stands for digital mobile radio. And so I found out my radio has that button on it, so I need to figure out how to make it work. But it's a technique for multiplexing two digital signals. So they take two digital signals and put it together in a nice narrow 12.5 kilohertz repeater channel. So it's not as big as what FM voice could be, but it allows you to go through like a hotspot or an internet gateway, and then you're able to link into talk groups with their unique IDs, and you can talk to people. Like if I have my radio connected to a node, I can talk to people in Brazil or wherever else I have my talk group at. So it's not directly going like through the airwaves like we're used to. It's going to the internet and then connecting with another repeater elsewhere, which seems kind of interesting. And then there's also this WSJT, which I couldn't figure out what the JT stands for, but the WS stands for weak signal. And so it's this bunch of software that's used for talking in really poor conditions. So for instance, meteor scatter, moon bounce, beacons.
Moon bounce. What's that mean?
So I can transmit signals off the moon and back.
Ah,
Mr. Scribner?
I just read that JT question, that's the guy named after the guy.
Okay, named after the guy. So what's his name?
John Stevens?
John Taylor? John Tyler? Jonathan Taylor?
And,
Okay. So this is a free, like, open source. So you can just go download it if you want. Go home, download it tonight. And so that's software that you can run on your computer, connect that to your radio, and through a USB cable or special cable, depending on whatever you got. And then you're able to control and send signals from your computer to your radio to then go over the airwaves. Or if you've got, like, with moon bounce, you're talking about shooting a special antenna, sending a frequency to the moon and bouncing back to anybody that's on this side of the earth at that time. So, and that's really weak signal. Moon or meteor scatter, you're talking about like very short openings in communication. So yeah, the weak signal propagation, some people really love that. Some people hate it. I don't know. Just fun to play with. But you do need to know that WSJT is for weak signal propagation. Or weak signal communication, excuse me.
This is gonna sound a little bit lazy.
You like it easy and make it work.
Well, yeah. Okay, on CW, because it's narrow, it's very efficient, you can get the signal out no matter what. Is there a way, since they're using a lot more computer interfacing, Is there a way instead of you keying, you just type your message and it sort of sends a Morse code out? You're kidding me.
Yes.
In the same way you receive it, you can.
And then
see it?
your computer could encode and decode CW for you. Tom would want you to use a keyer though.
I understand that.
But, if you needed to get a signal out.
I've been communicating forever, just one sentence.
Well, until the early 2000s,
I know,
this test
I know,
required.
I know. That's why I never did it.
Yeah. So we've talked about radio signals, and now we want to talk about safety. And some of this is common sense, so that's why we're kind of going to talk about it. But electricity can kill you. Newsflash. So not signals. Stop talking about signal. So voltages as low as 30 amps and current as low as 100 milliamps or 1.1 volt or 0.1 amps can kill you. I've been shocked with more, and will probably continue to get shocked with more, but it depends on where it goes through your body. If it's going right across here, or like it's really more back and forth here, and going through your heart and disrupting your SA node, you're gonna have a bad time. If it's going through your hand, which is where I usually get it, you can take a little bit more, but as long as you have, don't have an electric path going through, your thoracic cavity, don't really want that. Because electricity disrupts electric signals, heats up your tissues, and causes involuntary muscle contractions. You do need electric signals in your body to keep it going, but if you have a lot of electric signals, you can shut that down, and that's not fun. Grounding. Grounding is important. When you're working on equipment, you want to ground yourself so you don't have a static charge to destroy your specialized pieces of equipment. But your grounds should have, when you're plugging your equipment into the socket, make sure that you're using all three of these little prongs, because the bottom one there is your ground. And so if you're using AC equipment, make sure it's grounded. If you're, you've got multiple pieces of your station, you've got a tuner, you've got a power supply, you've got your rig, connect them to a common ground. And, make sure you have a ground fault interrupter on that circuit, just so if there is some sort of power surge, your equipment's not fried, because that would make you very sad. Another bit of electrical safety is fuses. So fuses are a mechanical interrupter. So it will physically, in your car, you've got fuses, and they've got a 5 and a 15 and a 30, and those tell you its rating. Do not put a 30 in the 5 spot, because then you can get a lot more current going through that spot where you shouldn't have that. So that's there for a safety reason. And if you put 10 amps through that 5 amp fuse, it will blow. That little squiggly thing in there is a fine piece of wire that's calibrated to blow if it gets more than 5 amps through it. Keeps it from having excessive current go through there and damaging your equipment. Capacitors. This one I've run into a lot. They store energy even when the circuit is not powered. And I've got caught by that a lot. Not fun. Bad words have been said.
You
Well,
have
Strip.
sworn.
And 12-volt storage battery. So we're talking about if we're talking about sealed lead acid or lead acid battery or any 12-volt battery, really. Like the one we're talking about out of your car. Shorting the terminals is a bad idea because you are actually causing a really high discharge on that device. And that discharge can overheat the battery, release explosive gases, cause the thing to explode, and cause burns and, shock and stuff. That's not cool. So be safe when using electricity. Make sure you put the positive where the positive go and the negative where the negative goes. Ground your rig. So if you've got a mobile rig, didn't specifically say that, but if you've got a mobile rig in your car, run a grounding strap to your engine block or something so that it will hopefully not get fried. And then also make sure that your starter is properly wired, because when you crank that, if it doesn't have a proper ground, it's gonna find the easiest ground, and if that's through your radio, you're gonna have 600 amps going through your radio, or however many cold cranking amps.
Your skin.
No, through your radio, and your radio's gonna get fried, because the finals don't like that much current. Antennas. So when we start getting into, putting these things up, like
You
antenna
wanna put
towers,
them up high.
you want to put them up high. High is good. Low can work, but high, people like high. Watch out for overhead power lines. They tell you that when you're a kid. If your antenna system falls, make sure that no part of it, even if you've got like a big beam sticking off of it or a big dipole, make sure that if it falls, no part of it comes within 10 feet of power line, because that's bad. And then when you're working on a tower, even if you have like a small tower at your house, use the buddy system. Wear hard hats, safety glasses, or fall arresters, so climbing harnesses. And then if you have an extendable tower, so they have like crank up towers where you have like several sections and you kind of crank it up to raise it to the highest level. Don't climb the extended part, crank it down to work on your antennas. And then also there's turnbuckles, which, what was that? Huh. So the turnbuckle is a specialized piece of equipment that keeps vibrations from loosening your guy lines, and that can cause your tower to get wobbly and or fall over, and that's not cool. Jacob?
I think I know what you're talking about. It's a piece of equipment that has two hooks on the end, and it has these bolt-like screw indents, and the middle part is just like a thing where you can shove something in and twist it around over and over and over until you're happy with how tight it is. And then the bolts come in more and more and more because you're tightening them.
Well, as long as, so when your antenna system is taking on a wind load, that will cause, as the wind's going through those guy lines and through your tower, it will cause vibrations. And so if you don't have a system in place to dampen or decrease or completely nullify those vibrations, whatever you're using to put your guy lines in can work itself loose. And if you've got a big tower, that can cause big problems. If you have a small tower, that will still cause a headache. And so I also want to talk about electric safety with towers. Ground them. So the thing that the test really wants you to know is that you need to ground your towers. Ground everything. Just ground everything you possibly can. Just go lay out on the grass. Don't ground your antennas, because then you get all sorts of loss. But ground the tower holding your antenna. Ground the cable that goes from the antenna to your station, but don't ground the antenna. So then I guess you could get some signal out, but not good. So one thing is to check local codes. It's not going to specify that in Massachusetts this is your building code, so this is a test that's given all over the United States. Just check your local building code. And then the one thing that they do mandate is attaching an 8-foot long grounding rod to each leg of your tower. Make sure it's properly attached to your tower, bonded with your tower. And so if you've got 4 legs of your tower, or your tower's a tripod and has 3 legs, so you've got 1 8-foot ground rod, 1 8-foot ground rod, 1 8-foot ground rod. They also want you to connect those ground rods as well through some means. They recommend like a heavy wire or a grounding strap, but make sure that they're connected so that if lightning were to hit the tower, we try to get that energy kind of dissipated through the earth.
Why 8 foot? Are you talking about into the ground? Why 8 foot?
That I'm not sure. It probably has to do something with how grounding works, but
Well,
I
the
bet
reason I answer is I had to upgrade my house up in Virginia from 220 to so I could take RC. And I had to put an 8 foot rod into the ground. I wondered why 8 feet. I didn't know that. I still would like to know.
That's the longest you can possibly handle that step ladder.
Okay.
So just so a normal person can.
Okay, I got it.
Okay. just ground it to the water table. I don't know. Something that would work.
Also in Wyoming, you have to do two.
Do,
Do two ground rods for a normal house,
oh, okay.
because our soil is so,
Dense.
So dry.
it's so dry.
Yeah. So yeah. Maybe your local electric codes.
Isn't the water table only like 10 feet below the ground?
Some places it's real deep.
Not here.
So that goes.
Uh,
If it's about our water table, we're just gonna.
Uh,
So it's just
1 minute.
good point to do that. But again, check your local electric codes, because if Wyoming mandates more, have more. And then avoid sharp bends. I mean, it doesn't really make too much sense to me, but electricity doesn't like sharp bends. Similar to if you put air through a pipe, you know, if you have bends in there, it decreases your flow rate or your
It
flow
arcs.
pressure. What?
It arcs.
Oh, so it arcs between the bend?
Yeah, I think so. I think that's what it is. That's the way I saw it.
In the old days, when they had those electric soldering guns,
Yeah.
all that is the copper wire coming back and it's hot at the tip, because that's where
So it just arcs.
the bend.
Oh, okay. And make your connection short and direct, because electricity likes the path of least resistance. Short, direct, that's good. And then the lightning protection for inside your station. So if you've got like your antenna, your coax coming from your antenna, make sure there's lightning arresters that they build for that connection. So you don't have this nice path for that electricity to come into your rig and destroy your nice things. You can then have a lightning arrestor on a metal plate that's specifically grounded, and that way that the lightning might hit that and then go to your ground instead of coming to your station. Also, if you're expecting a storm, you should probably disconnect your equipment anyway, like disconnect it from your outside antenna. But yeah, try to keep it grounded. That's safe. All right. And then lastly, I want to talk about RF exposure. So we talked about it earlier. So your body is affected by radio waves. It's a matter of principle. No matter what radio wave, you're affected at some point. 50 megahertz though is like the sweet spot for cooking a human. As gross as that sounds, that's the spot where. Oh wait, I don't have that. That's on the next slide. Never mind. But do not touch your antennas. If I've got my little radio here, it's putting out 5 watts. If I, have it right here and I'm talking and this is right next to my face, that's not a big deal.
It's cooking your brain.
It's not to the point where I need to monitor my RF exposure. If I've got a 100-watt antenna and it's sitting right next to me as I'm trying to transmit, that could be a potential for RF burns. And so that's why we've got, so RF radiation is non-ionizing and non-mutagenic, so it's not like radioactive radiation, it's RF radiation. And so people like to say radiation like, oh my gosh, that's bad. Well, it's just talking about how it's propagating, it's radiating out. So it's not ionizing, non-mutagenic. So it's not like it's gonna turn you into a mutant or anything. It's just radiation that has a signal. But it can still give you a burn. And again, above 50 PEP, the peak envelope power, that's when you gotta evaluate your RF exposure. So there's 3 things here. You can do computer modeling. You can use the FCC OET Bulletin 65, which I found and hyperlinked here. That'll put you to sleep. Or you can actually get a calibrated field strength meter to then go and stand next to your antenna, transmit, and see how much power is actually being generated. So like a watt meter type thing.
I have a question. It doesn't relate to the radio, but I think just my knowledge. How does 50 peak relate to joules? You talked about the waves affecting the SA node.
Yeah.
Yeah. So when you stock a patient, you use so many joules. How does it compare to 50 peak?
I don't know, but I will look that up. So,
Thank you.
all right. Got my planning hour tomorrow morning, so I'll look that up. And so another thing that's important with your RF exposure is duty cycle. So if I have a station that's operating like 1 minute out of every 10 minutes, well, that's a 1 in 10 duty cycle. So I'm only 10% of its time transmitting. So if you have a duty cycle that's, really high, then we want to take that into consideration when we're doing our RF evaluation. If you're mostly listening and transmitting very rarely, that also goes into your RF evaluation, because we like to look at average exposure. So if I'm in an area where I'm getting high levels, but it's for a very, very short amount of time, unless I'm like really, really close to the antenna, that might not be so bad as if I'm in an area right next to an antenna with lots of low exposure. But duty cycle is important, and that's how often your station is transmitting. And so, like we talked here, 50 megahertz has the lowest permissible exposure rate limits. So 50 megahertz, for some reason, is the sweet spot where it affects your tissues the most. Maybe it keeps the water inside your tissues. I haven't looked that up too much. But 50 megahertz is the one that we're most concerned about. So down on, if we're on 40 meters, like we're about 7 megahertz, that's not as bad. Most of this stuff up here, the UHF, VHF frequency is 140s to 480s, 440s. Like, that's not so bad because that doesn't interact with my tissues as much. But 50 megahertz, is that about 6 meters? That's the sweet spot, and that's the one we're most concerned about. And so some primary things to take into consideration in your RF evaluation: location of your antenna. Is my antenna right next to me? Because that's a really big concern. Is it in an attic? Is it in an attic next to a bedroom where a child's sleeping? Is it up on the roof? Is it 30 feet up up on a tower? Those are things to take into consideration. What frequency and what's the power? Like this thing, I'm transmitting 5 watts on a frequency that is not of huge concern, because 50 megahertz is our big concern. Not as concerned with for RF evaluation. And what's the radiation pattern of the antenna? When we talked on week 1 or 2, we talked about like directional antennas. If you're standing right in front of the main lobe of a directional antenna, you're getting a lot more radiation than someone that's standing to the side or even behind it, which you'll get a little bit of radiation, but to the side, like that's not so bad. But standing right in front of
It's
it,
always bad for you.
True.
It
But-
lowers your ability to fight colds and diseases, and it actually, and because good bacteria in your body doesn't regenerate as fast as bad bacteria, when you irradiate your body, you kill all the good and bad bacteria, and then you have to be in a hermetically sealed room for the next month
okay.
in order to grow your good bacteria back, if you can at all.
And so one last thing with that is when you have any changes to your station, putting up a new antenna, getting a new transmitter, whatever, you should reevaluate your RF exposure just to be on the safe side. Whether it's computer modeling, whether it's checking it out, making sure that you're not frying your neighbors. Like those are important things. Being a good neighbor also involves making sure that you're not bathing them in RF radiation. So next class, I want to talk to you guys about, I forgot to write the topics next time, but make sure that you read pages 53 through 64. So it's another shorter section, but we talk about, some good stuff here. We're going to talk about, station setup and station equipment. That'll be a fun one. So I'll get my station out here so we can talk about the different parts and pieces. And don't forget, in between here, write any questions you have and check out that hamstudy.org to do some practice. So hopefully you guys got some good feedback on your practice test. Again, you just saw 35 questions out of a potential pool of 420. Janet, was it 422, 426?
426.
426. So there's still like 390 questions left that you haven't seen. So make sure that you go check the flashcards. We cover some as we go through this material, but make sure you check the flashcards. We're covering the big concepts, but there's some particulars that sometimes flashcards are just good to cover. Any other questions? All right. So next Monday, same time.
I'll make something safe now.
Oh, no.
On that hand
Tomorrow?
thing, the more you take it, the more you get used to the questions.
Some of them probably.
No, this is different from last week.
No, they're the same wording, and even the answers are the same
Yeah,
wording
I'll-
as the ones that you'll
No,
find.
no, no, that's not what I mean to that. Out of 400 odd questions, there's something very similar.
Oh.
in-
So yeah, there's some of them where they'll have like 10 questions that are about how to calculate frequency in megahertz from a given wavelength.
These questions we had tonight were some of those questions.
Yes, those were pulled straight from the, I took them off this, whatever this website is, hamexam.org.
Yeah.
So I just asked for a current technician
Practice
question.
on that website.
I was just thinking about the,
You're gonna say, it's what
Some regular school.
Grading that test, every one of you guys, every one except one person said FM is the best for long range and low signal range. Sideband is more efficient than FM. And it has better coverage. And everybody, there was one person that said sideband,
Not me, I didn't say that, I know that.
said FM.
Yep.
Because that's what everybody knows.
And when I saw the SSG, I didn't even think about what it was. And I used to operate CB radios when I was in college.
Oh, that's also
I
SSB.
didn't think about, well,